Hello everyone. So again we have an integration where we have to integrate this function on a unit circle with center at origin. Okay, so unit sphere with center at origin. That means we have our axis x, y and z, and we are going to just imagine a sphere whose radius from the origin, that is 0 0 0, to the surface, that will be 1 unit. Okay, we are using unit sphere. Alright, that means the boundary is x square plus y square plus z square is equal to 1 is the boundary. Alright, or we can write this is a solid sphere, so the boundary will be 1 and everything below the boundary will be less than 1. So we know our spherical coordinate. So what we are going to do, put x is equal to rho cos theta sine phi, y is equal to rho sine theta sine phi, and z is equal to rho cos phi. Okay, these are our spherical coordinate, and without fail the Jacobian, that is rho square sine phi. So since we are changing the variable from x y z, if we see to to rho theta and phi, we need to multiply by the Jacobian. Okay, so now the limits. So we know that theta. So for this, the base is this circle theta. So theta will be from 0 to 2 pi. So that is in xy plane. All right, and the radius we know it is growing from 0 to 1, so 0 less than rho less than 1. Now for the limit of phi, we know that if we rotate it, if we keep a coin like this, and if we rotate by pi degree, so there are two sides of the coin. If we see, so one side will trace this region. If we see, this is tracing the right region. Similarly, at the same time, the lower end of the circle is tracing the upper half of the sphere. All right, so the two sides will trace the two region. We can imagine it as this is our unit sphere, and when we rotate it by pi degree, so slowly we can see that one part is the upper part of the circle is tracing the right side like this, and the lower part of the circle, that is something like this. So it will trace. So the lower part of the circle will trace the other side. Okay, so the only rotation required here is 0 less than pi less than pi, because if we look at the one section of it, so the lower end will trace this side and the upper end will trace the right side. Okay, that's why we have taken a complete circle. Now doing the change of variable, so therefore triple integral s e raised to x square plus y square plus z square raised to 3 by 2 dx dy dz will now become equal to triple integral. So this is our rho square. We know that x square plus y square plus z square, if we take, we are going to get rho square. So e raised to rho square raised to 3 by 2 into the Jacobian, that is rho square sine phi, and then we can take any angle. So we will take d phi, d theta, d rho to tackle easily. Okay, and phi we know it is from 0 to pi, theta we know it is from 0 to 2 pi, and rho we know it is from 0 to 1. Alright, so this is now equal to 0 to 1, 0 to 2 pi, and this power law of indices will give you rho cube. Alright, and rho square is already there, and we will take this integral inside 0 to pi sine phi d phi, and outside we have d theta d rho. Okay, so we know that integral 0 to pi sine phi is nothing but minus cos phi 0 to pi, and that is minus cos pi minus cos 0, and that is going to minus 1, or finally we can say it is 2. So therefore our question now reduces to this. I can put it 2 and constant I can take out. So we will get, which is equal to 2 times 0 to 1, 0 to 2 pi, and rho, if we take the total power, it is 5. So rho raised to 5 d theta d rho. Alright, so this is 2 integral 0 to 1. Rho is a constant with respect to theta, so 0 to 2 pi d theta d rho. Okay, and this is nothing but theta. Integral of d theta is theta from 0 to 2 pi, and that is going to be 2 pi finally. So that is a constant which I can take out. So it is 2 pi integral 0 to 1 rho raised to 5 d rho. Okay, so this is 4 pi and this is rho raised to 6 by 6, 0 to 1, and applying upper limit minus lower limit, so that is 4 pi 1 minus 0 by 6, or simply 4 pi by 6, or you can say 2 pi by 3 is the final answer. Okay, thank you.